Hello, Darren here. Today we'll be looking at our first topic of math methods. What you see on your screen now is taken from the Math Methods Study Design, and it is part of Area of Study 1. So you do have a lot of different books which teach math methods, but this is what VCAA has said needs to be covered. It's a very useful revision tool to go over at the end of the year to make sure you've covered every single thing that VCAA could test you on, but we'll also be going through it to teach you guys the content as well. Beginning with the first dot point, I've broken it down into 4 videos because I remember I quite liked short videos that taught me everything that I needed to know rather than a really lengthy video. So the 4 videos are, firstly, this one, which is what is a function. The next video will cover power functions, the next one will cover exponential and logarithmic functions, and the 4th video covering the first dot point will be on circular functions. Okay, so what is a function? Well, a function is a special type of graph. And we all know that graphs come in all different sorts of sizes, such as this, or this, or this, or even this. So that begs the question, what makes a function special? I like to think of it as a rule of exclusion. What this means is that if a particular graph fits this rule, then it cannot be considered a function. The reason I think a rule of exclusion works well is because there are different types of functions, so it's much easier to think about what isn't a function first. And the rule of exclusion is this. If for one x value there are multiple y values, then the graph is not considered a function. The next rule isn't so much of a rule because a function doesn't have to satisfy this to be a function. However, this is something that people commonly misunderstand. So, if for one y value there are multiple x values, then the graph can still be considered a function. Let's have a look at this graph here. Looking at this x value here, you realize that there are y values here, 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 and here. And since on this graph, one x value does have multiple y values, this graph is not a function. Let's have a look at this second graph here. We can look at this x value here, or here, or here, and you realize that no matter what x value you take, there is only ever one y value. However, if we take one y value here, we realize that it reappears at many points with different x values. Therefore, this is a graph where, for one y value, there are multiple x values. However, for one x value, there is only ever one y value. And so this graph is still a function. Now there is a shortcut rule which is founded upon the theory we've learned that if for one x value there are multiple y values, a graph is not a function. Now this rule is called the vertical line rule, and essentially you draw a vertical line, and if that line passes through more than one point on the graph, then the graph is not a function. You can see how it kind of works because a vertical line tests whether for one x value there are multiple y values. And just to end off the video, I'll go into the 2 really important types of functions. As I said at the start of the video, it's much easier to think of what a function isn't to begin with, but you do need to know the types of functions because they're useful later on for things like inverses. So the 2 types are many-to-one functions and one-to-one functions. Now the way of understanding the phrase many-to-one and one-to-one is like this. Many-to-one means that there are many x values for one y value, and one-to-one means for every x value there is only one y value, and vice versa. And using the tests which we've just learnt, a one-to-one function passes both the vertical line test and the horizontal line test, whereas a many-to-one function passes the vertical line test but fails the horizontal line test. Keep in mind that one-to-many graphs are never functions because they fail the vertical line test. If you're ever struggling to recall what a function is, please keep in mind the example of a humble parabola, because a parabola is the perfect example of how a function can have a y value which maps to multiple x values, but each x value must only map to one y value. Hope that helps.